Welcome back, Algebra students. This week I'm going to record actually two videos to kind of separate them. I'll tell you when we do this in class, I usually take 3 to 4 class periods on just this topic. So last week we solved quadratic equations by graphing them and seeing where does the graph cross the x-axis. This week we're going to solve them by factoring, okay? Remember, it's still the same thing. We're still finding what we call roots, zeros, or x-intercepts. So that means when y is 0, what are our x values to make that equation true, okay? So here are the 4 steps. First one, set the quadratic equation equal to 0. Okay, so we want to replace this variable y as 0, okay? Now, second step, it does say factor the left side, so I'm going to keep all of this stuff on the left side. So I'm going to rewrite this as x squared plus 3x minus 10 equals 0, okay? So that's the first step. Second step, factor this left side. So remember, Miss H taught you how to factor. I personally set up my 2 binomials based on the c value. So the c value is -10, so I know that one of these has to be plus, one of them has to be minus. That way we can multiply the last terms to get a negative. Okay, remember we want to then figure out, well, what multiplies to -10 and adds to +3. So, oh goodness, -10, what multiplies to -10 and then adds to 3. So let's see, we have -5 and 2, and those will add to, -3. That doesn't work. So let's try the other one. 5 and -2 multiply to -10, and they add to +3. Good. So the positive needs to be the 5. The minus is 2. Remember, you could always check your work and distribute x squared minus 2x plus 5x. That gives us our plus 3x. And then 5 times -2 is -10. So it works, okay? Now what we do from here is we set both of these equal to 0. So step 3, set each factor equal to 0, and then solve for that x. So that means this binomial, x plus 5, set it equal to 0, solve that equation. So -5 from each side. This is a one-step equation, okay? We just want to get x by itself, so x is -5. Do the same thing with our other binomial, x minus 2 equals 0. So we would add 2 to both sides to get x by itself, so x is 2. So our two solutions, last step there, step 4, write your answer using curly braces. So x equals, we have -5 and 2. Remember, this isn't an ordered pair. There are 2 solutions to this. All right. I am not going to do all of these examples because there are a lot on here. I kind of planned ahead and chose 4 on this front side. They all have different types. So this one, for number 1, has plus plus. Then we have a plus minus, a minus minus, and a minus plus. So I covered all 4 types of examples, okay? So first step, set it equal to 0. It's already done. We don't have to do that, okay? So we're going to factor our polynomial, okay? The all plus signs are easy because we know they both have to be plus. Set it equal to 0. So what multiplies to 4 and adds to 3? We have, let's see, 4 and 1. Oh, sorry, multiplies to 3. I am off on my factoring there. Multiplies to 3 and adds to 4. So 3 and 1 is our only possibility because it's prime. So 3 times 1, and then adds to 4, and that works out. I'm kind of doing that part in my head, the double checking that it factors, or it multiplies back to that polynomial, okay? Then set them both equal to 0, so x plus 3 equals 0, x plus 1 equals 0, and solve for those. So -3, so x equals -3, minus 1 on both sides, so x also equals -1. All right, So x equals -3, -1. All right. It doesn't matter the order you write them in. I often like to write the smaller number first. Totally doesn't matter though. Okay. Next example. Again, already set equal to 0, so we just have to factor. Now, this example, our C value is negative. All right, our middle value is positive. So this is kind of like that first example we did up here. We know one has to be plus, one has to be minus. That way, when we multiply the last terms, we can get a negative or a minus. Okay, so what multiplies to -27 and then adds to +6? So multiply, add. Let's see. I know that since the middle term is positive, so I know that the bigger factor has to be positive. So let's think 9 and -3. They multiply to -27. They add to 6. There we go. So +9 -3. Again, I check that in my head. X squared -3x plus 9x. That works. And multiplies to -27. So I'm doing my FOIL. Okay? Set them both equal to 0. And then solve for x. So -9, x is -9, plus 3, x is also 3. So x equals -9 and 3. All right. Let's keep going then. This one we have already set equal to 0. We have, again, the C value is negative. So I know one has to be positive, one has to be negative in order to multiply to a negative. This case, the middle term, B, is negative. So the bigger term has to be negative in this case. So we want them to multiply to -20, and we want them to add. Remember, there's a 1 in front of that x, so we want them to add to -1. So the bigger term is going to be negative this time. So let's see, -5 and 4 multiply to -20, and they add to -1, so that works. So x minus 5, x plus 4, and then we set both of those equal to 0. Again, I'm going to double check. X squared minus 5x plus 4x, that works. And then 4 times -5 is -20. So x plus 4 equals 0. X minus 5 equals 0. So x is -4 and x is 5. And I'll write it with my squiggly parentheses. And there we go. Okay. One more example on this side. We have, again, set equal to 0. So x and x. Now this scenario, we have a C value that's positive, okay, but the middle value, the B value, is negative. So we know we have to have a negative in here, and the only way to get this last value positive, well, that's a negative times a negative. So they're both negative this time. What multiplies to +16, but adds to -8? Let's think. 8 and 2 aren't going to work. 4 and 4, so -4 times -4, they multiply to +16, and they add to -8, so that works. All right, so x minus 4, x minus 4. All right, now these are the same. So when we set this up and we do x minus 4 set equal to 0, x minus 4 equal to 0, and we solve them, well, both binomials, we're going to get x equals 4, x equals 4. So this is a scenario where we have only one solution, that is 4. Okay? So all of those we had a values of 1. Let's flip to the other side. We'll do a couple more here. Notice this one doesn't have a C value. If we don't have a C value, you've got two scenarios. We can either pull out a GCF or we have a difference of squares. In this case, we do have a GCF, okay? And I forgot to tell you, on those last examples, always check for a GCF first. But those last examples we didn't have a GCF. In this case, between 8 and 6, we have a GCF of 2. Between x squared and x, they do have one x in common, so 2x is our GCF, all right? Divide 8x squared, so we're going to get 4x, and then minus 3. I took 6x divided by 2x as well. Okay, I always double check, is it going to distribute back? So 2x times 4x is 8x squared, 2x times negative 3 is negative 6x. Okay, now in this example, we're going to set both of these, this monomial and this binomial, set equal to 0. So 2x equals 0, and then 4x minus 3 equals 0. Okay, so this one, if we divide both sides by 2, 0 divided by 2, so x equals 0. There are times that the graph crosses at the actual origin, 0, 0. So x equals 0 is one of our solutions. Now this other one, this is going to be a two-step equation. So add 3 to both sides, 4x equals 3. Divide by 4. Now 3 we can't divide perfectly by 4, so remember we can keep it a fraction. So x also equals 3/4. All right? So x equals 0 and 3/4. All right. Let's look at this one. Now, 13 does not have a GCF besides 1. So this is an example. I know that this is a perfect square root. So this is one of our difference of squares. So x, the square root of 64 is 8. X minus 8, x plus 8. When we do the opposites, those will cancel out, and that's why we don't have the middle term, the b value, okay? X squared plus 8x minus 8x, that's where they cancel out. And then negative 8 times positive 8, we get negative 64, okay? All of this we learned in our factoring unit, okay? Set them both equal to 0, and then solve. So x equals 8, and x also equals negative 8, okay? Difference of squares, they're always just going to be the opposite numbers. Do my little squigglies, and there we go. All right. Now, this one, notice that we have no GCF, because nothing can go into 4 and 81 perfectly. But this is a perfect square root, and this is also a perfect square root, 4 and 81. So take the square root of 4, and we get 2. So 2x and 2x. We know that the signs have to be opposite in order to cancel out the middle term, so we have no b value. And the square root of 81 is 9. Okay, and double check. 4x squared minus 18x plus 18x, there's where they cancel. Positive 9 times negative 9 is it negative 81. Okay, again, set them equal to 0. 2x plus 9 equals 0. And 2x minus 9 equals 0. All right, and then I'm going to kind of do this in my head. We subtract 9, divide by 2. So x equals negative 9/2. And then also add 9 and divide by 2. That's just solving a two-step equation. So x equals positive 9/2. And we write them with our squiggly brackets. All right. All right. Now, what happens in these last two examples? They aren't written in standard form. If you notice, the right side has a term. They always have to be set equal to 0. So the first step in these, the equation's not in standard form. All of these, we have to rearrange them first. So we want to move that 4x. So I'm going to subtract 4x to get 0 over here, and then we also have to subtract it over here. So I'm going to write it in standard form, so x squared minus 4x minus 45, so that's our ax squared plus bx plus c, and now it is equal to 0, okay? Now we would go to that second step and factor. They're both minuses. Since the c value is a minus, we know one has to be plus, one has to be minus. We know the bigger term has to be negative because the b value is negative. So what multiplies to negative 45 and then adds to negative 4? So I'm thinking 9 and 5. So the negative has to go with the 9. Negative 9 and 5. Multiply to negative 45. Add to negative 4. So that works. So then x minus 9, x plus 5. And then we can set both of those binomials equal to 0. So x equals negative 5 and x equals positive 9. All right. And the last example is very, very similar because we have to rearrange the equation. I like to keep everything on the left side, so I'm going to subtract x squared, and then I'm also going to subtract 8x and subtract it over here. So rewrite this 11x squared minus x squared. Those are like terms, so 11 minus 1, we get 10x squared. The minus 8x comes next. We don't have a constant, so we simply stop there, and that equals 0. Okay? Now, again, when there's only two terms, it's either GCF or difference of squares. We have a GCF of 2x, so I'm going to pull out 2x, divide the 10x squared. Oops, no squared. And then minus 4, that equals 0. So this is kind of similar to that example on the other side, where 2x equals 0, 5x minus 4 equals 0. So divide by 2, one of our solutions is 0. Add 4, divide by 5, so x equals 4/5 as well. And I'll write that. And there we go. All right. There are some extra examples on there you could try and check in with me. Remember, I am writing on these, so all of these notes are available to you on Shobi. Okay. I'll have one more video, and that will include what happens when the a value is greater than 1 and we need to factor. All right. Thanks for listening, guys.